Okay, fifth years. I've had a couple of comments from people who are having a couple of issues with the clockwise, anti-clockwise moment. So I wanted to run through a video correction of question 8 before you try and attempt the rest. If you are having any issues, if you're not, of course, just crack on. If you are, or if you see mistakes that you've made after you see this video, then we might need to go back and redo some of the problems. So this is question 8 from page 237. I've got a quick sketch of the diagram from the textbook. I've redrawn it there myself. The question asks, you've got to calculate the total clockwise moment about the 0 mark and the total anti-clockwise moment about the 0 mark, and show that they are equal. So you can see I've got the diagram drawn there, and the 0 mark is where 0 is on the meter stick, which is here. So we are talking about the clockwise and anti-clockwise moments from that position. So the ones that are clockwise are the ones that are going in that direction, and you can see that there are 3 of them, and the ones that are going anti-clockwise are the ones that are going in that direction, and there are 2 of those. Now that's in relation to the 0 mark. The 3 that are pointing downwards are going clockwise from here. So if I look at those from the 0 mark, clockwise, clockwise, clockwise. And then if I look at the other ones from the 0 mark, this one is anti-clockwise, this one is anti-clockwise. So that's what we have to keep in mind. I'll get rid of those now, and we can see the calculations underneath that I've done. So about the 0 mark, the clockwise ones are this one, number 1. It is 10 centimeters away from the 0 mark, or 0.1 meters, and there's a weight of 2 newtons. The second one is 50 centimeters away from the 0 mark, or 0.5 meters, and it is a 1 newton weight. And the third one is 66 centimeters away, or 0.66 meters, and it's 1 newton weight. So we've got the 3 of those, multiply them again, force by distance gives us our newton meters, and I add the 3 of those together to get the 1.36. Now remember, this is all to do from the 0 mark, from this position. The anti-clockwise ones are the ones pointing upwards in this instance. You've got the 3 newton weight, or the 3 newton force, whatever you want to say. That is 22 centimeters away from the 0 mark. So it's 0.22 meters, and it's 3 newtons. And then the one at the far end over here is 70 centimeters away from the 0 mark, or 0.7 meters, and it is a 1 newton weight or force. So again, multiply force by distance to get your newton meter values, add them together, and you can see that the clockwise ones add up to 1.36 newton meters. The anti-clockwise ones also add up to 1.36 newton meters. Therefore, they are equal. Now, that's the straightforward section. I would hope now that I've explained it and you can see what's happening and where we get the idea of clockwise and anti-clockwise. The second section in this is a little bit trickier, but it is the same process. So we have to do it about the 70 centimeter mark now. So I now take this part here as my fulcrum. I treat this like we treated the 0 mark in part A. So because this is the fulcrum, I don't need to worry about this 1 newton weight here. I forget about that, because that's at the turning point, so there's no force being applied there, either upward or downward on the fulcrum. If I push the fulcrum up or push the fulcrum down, it will change its position, as in it'll get higher or lower, but it doesn't make the meter stick rotate left or right, if you understand what I mean. You can imagine if I've got the meter stick there and that's my fulcrum, I can move that downward or I can move that upward. That's okay. But if I added a weight that's obviously going to make the stick turn, and it's going to end up in that kind of orientation. Or if I add a weight here, it's going to make it turn and end up in this orientation if it was weighed down at one side. So the weight at the turning point is forgotten about in this instance. So you can see at the 70 centimetre mark, which I've marked in gold here, I've got my clockwise moments. Which of the weights, I've only 4 now I'm looking at, 1, 2, 3, 4, which of those 4 do I need to think about moving clockwise in comparison to my turning point? So which ones are going clockwise? And you can see I've got 1, 2, 3 going down or moving around to the left of the fulcrum, which is the 70 centimetre mark in this case. And in this instance, I've got 1 that would be moving up to the right, and that is moving in a clockwise direction, orientated to the 70 centimetre mark. So I've only got 1 clockwise moment in this case. Now, it's a 3 Newton weight, that's no problem. 0.48 is where people will have the issue. I have to say it's the distance from the fulcrum to the force. So I need to look. Remember, that's the 70 centimetre mark on my meter stick. And I need to look at the difference between 70 and the 22. So to figure out the distance from the fulcrum to my 22 centimetre mark, I got to do 70 minus the 22. And that gives me 48 centimetres or 0.48 metres. That 3 Newton weight is 48 centimetres away from my fulcrum in this instance. So it's all to do with the position of the fulcrum, and we have to keep in mind what that one is. So I know that that's my clockwise one now, and I've got 0.48 metres away from the fulcrum, and it's a 3 Newton weight. I multiply them together. The other 3 are the ones in this case are all pointing downwards. They're the anti-clockwise ones, 1, 2, 3. And again, the tricky bit, or the bit that people will probably get tripped up on, is getting the distance from 70. Okay, so look, we've got 66. That's 4 centimetres away from 70. I've got 50, which is 20 centimetres away. And I've got 10, which is 60 centimetres away. So they're all my distances. And the weights are given to us, 2 newtons, 1 Newton, 1 Newton. So I have them marked in. And then you multiply them out, add them together again, and we end up at 1.44 Newton meters, and they are equal. The anti-clockwise and the clockwise moments about the 70 centimetre mark are equal. So the tricky bit, as I said, is when the fulcrum moves. From the 0 mark, it's a bit easier because you can just count the numbers that are on the meter stick. But when the fulcrum changes position, you have to do this subtraction to get these values down here that I've just highlighted. And we got to keep that in mind in terms of which ones are actually moving in a clockwise direction and which ones are moving in an anti-clockwise direction, going like that. So keep that in mind, take your time, and see how you get on with the rest of the problems. Thank you.